I'm going to give you just a couple of minutes. If you're just walking in, set this one up, and then put your answer in the text box, but then wait to hit send. So if you've done it, just calculate it. No need for an exact value, so you don't need to do this by hand to set up. And then I'll know if you're on the right track if you are shooting out the correct answer. But just type it in and then wait. So I'm just waiting for a couple of people, got about a half a minute left. Just type in your final answer. Remember, you're going to 3 decimal places. You don't, somebody in my previous class said, something-ish. I'm like, wow. No, not really. I'm just waiting for, I guess, Connor and Gortej, Hannah, and Amy. You there, Amy? Just wondering if you have worked this out yet? Check through. Okay, go ahead and shoot out your answers. Sorry. Let's see if your eventual answer matches. So go ahead and shoot those out. Can you guys hear me okay? Oh, okay. Go ahead and shoot the answers out. So we have a lot of varied answers. Oh. So let's look at the setup for this. See if you set this up correctly. So we're talking about pictures are really tiny. But we're talking about from 1 to 3. If that's 2, this is 1. 3 is here. We're rotating it around the y-axis. So we're rotating it around this way. And because of that, everything has to be rewritten in terms of y. Oh, okay. So I've got a big radius. I've got a little radius. The function has to be rewritten, so instead of y equals things cubed, it would have to be the cube root of y plus 1. And then I'm integrating from 0 to 8 of pi r squared, big R squared, which is 3 squared, minus, I'm going to call this f of y, so that I'm not repeating it, f of y squared dy. So hopefully the ones that got, I'm looking for consistent answers. My other classes got weird answers, and I don't know why. And there, cutting them off. I should probably shut the windows. Hang on 1 second. Okay, so hopefully you got one something, 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 850. 160.850 or 49, whatever it would round to. Okay, so my question to you is, I want you to look at this problem. It's different, it's still cubic, but it's a different type of problem, and I want you to raise your hand. There's an inherent problem in this one. So if I'm doing the disk method, there's a problem with this one. I want you to tell me what is wrong if I were to use the disk method. And raise your hand when you can identify it. So just think about what's going on with this one. And then raise your hand. As soon as you identify what's going on with this one, where the disk method, there's a problem with it. So I'm taking that little loop and I'm around the y-axis. Can you guys hear me okay? It's so quiet. I don't know if you can hear me. So I know Amy can. Anybody else? Can you guys hear me? Oh, okay. Exactly. It's not a one-to-one function, right? So if I try to do this, and I'm trying to do the disk method, I love your vocabulary. That is so awesome. So I guess here would be my big R, but then my little r, what the heck? Here's my baby R. Well, this thing doesn't know where to stop. Do I stop here? Do I stop there? It's all one function. Ouch. What is going on? So give me just a second. I'm going to show you a, what is it called? An animation. So give me just 1 second. I'm going to show you what could you do, and then we'll do it. Okay, so I'm going to share my screen. And when you, I just want to know if you can see this. I'll do desktop. So can you guys see this? If you can just text in a yes or a no or something. Yes? Okay. So this is the little function that we have. I don't know if you can even see my cursor. I think you can. But here's the function. I didn't show this at my other classes. I couldn't get it running because I couldn't, whatever. This is supposed to be x equals 0. I couldn't make it 0. I don't know why. Let me see if I can move it. Ah, yay. So I'm trying to do that, and there's no fun way to do it, except if I use shells. So here's one rectangle. Here's another one. Original rectangles. Okay, so this isn't behaving. Hide original area. No, show reflected area. There's the reflected area. Revolve one rectangle. So the way to do this is to make these little shells. And we'll look at all. So do you see that? You got all these little shells inside of shells. And if I could make this a different scale without taking a billion years, I would do it. But you're looking at that little rectangle thingy, and this time it's going to be a nested shell. So that's what it looks like. That's what we're trying to do, but it's not a one-to-one function. So the question is, what did these people do to make it work? Here's another shell one. So if I revolve it, a little easier to see because it's a different function. But there's a shell to that outside one. So this little guy in here is what we're talking about. And notice it's a cylinder, right? It's a cylinder and it's sort of facing, I don't know what, like a vertical cylinder. If I sweep shells, so the shells are going out, the cylinders are getting bigger and bigger. You've got a dx, so the width of them are infinitesimally small. And I already did that. Let's see, what else? I don't know if this will, oh, this is the stuff that you did before. Disc washer, stack discs and wash. Oh, here's another one. So if you look at this, so there's a rectangle. I don't know, it's a rectangle, but it's really the height of the shell. And we don't do this. I'm not really sure why. It's kind of sad. But that's what they look like. So that's how you can fix this type of problem. All right, so let's do it. I'm not going to be doing this stuff. So, get rid of this. And that. And more of that. And even more of that. Okay. So, you already saw what it looks like. I'll draw a little, my crappy little thing here, but okay, so I'm taking this and I'm revolving it around. Like this. And I'm making all of these little shells. They're all going to be nested within each other. So the question is, well, how does that relate to the graph and everything? These are actually really simple. If I were to take one of those shell things, which looks like a hollowed out cylinder, and let's say I were to cut it. There's my scissors, and I'm cutting it right down here, and I'm going to lay it flat. So I've got this slab of shell. There's a much nicer way to do this, and do it the much nicer way. Just write it out. Here's the nicer way. So I've got a shell that looks something like this. Isn't that nice? I don't know why I didn't need to do that in my other classes. It's silly. Okay, so there's my slab. And in order to find the volume, so we're going to be doing all of these as little volumes. Volume, you know, is length times width times height. Here's my length, here's my width, and here's my height. So we got to think about, how do I get that? Well, the height is just this distance. So the height is just my function, x minus 3 squared times x minus 1. That will give me all of the heights. And notice I'm not rewriting this in terms of y. For two reasons. Number one, I can't. It's not possible. Because if I were to work this stuff out, I'm going to get something cubed, and then something squared, and then something to the first power, and then constant. And there's no way to solve that and get the x by itself. So that's not the actual thing. There are, like, whatever, there's coefficients and stuff. So I'm leaving it. My width is just dx. So that's this little tiny width right here that's getting smaller and smaller so that I have an exact volume. And then the length is the only thing that some people get confused about. Notice my length, I unwrapped this thing. So now I have this length, and that correlates with something having to do with a circle. Can you see what that length might be in terms of that upper circle or the lower circle? And think about geometry. You're a rock star. 10,000 stars for you. Did everybody see what Bonnie said? That length is the circumference of this circle, which is simply pi. Just kidding. Oh, there's a pi in it. I didn't want to write that. I wanted to write this. Is 2 pi r. Well, in this case, r is just my x. So in the length is going to be 2 pi x. So I'm integrating the length times the width times the height. I'm not even changing my interval. I'm still going from 1 to 3. So in rough form, you just said the length is 2 pi x. That x is really there as an x. The width is dx. And the notice nothing is squared because we're not using that. So if I were to actually integrate this and come up with a value and put everything in, there is a 2 pi on the outside, and then you've got x times x minus 3 squared times x minus 1. Yes, done. No rewriting, because I can't. And how simple is that? I'm not sure why they took it out of the AP. It's just a beautiful idea. And I remember when I first learned this, I went, oh my gosh, it's a slab. And I know all about slabs. Isn't that beautiful? So, give me a raised hand or something along those lines. Actually, just raise your hand if you understand what we just got through doing. It's just such a simply beautiful idea, I think. Okay, yes, all right, so that's nice. Let's see what happens in another type of problem. It's not a type of problem, it's the same idea. My function's different. I got the transcendental function sine x. My bounds, and I'm still about the y-axis, but my bounds are from pi over 4 to 3 pi over 4. And I'm doing sine. And again, this is not a one-to-one function unless you restrict it. So we're used to restricting those because if you don't do that, then you don't have you can't do inverse sines or anything. Inverse sine would have been from here to here. But this one keeps on going, so I can't just use inverse sine, which would have been fun. So let me shade in what we're talking about. This is 2 pi over here. This is pi. This is, pi, so bad. Get rid of that. Pi over 2. And here we're concerned with okay, so pi over 4 is like here, and 3 pi over 4 is like here. So I'm interested in this area, from here to here, and I'll shade it. Rotating this guy around the x-axis. And some of you might think, well, I could go from here to here, that's just a rectangle. But then when you get to here, you can't say, well, I'm just going to stop here, and then the function doesn't know to stop because it's not a one-to-one function. So I can fix that by not doing it with disks and washers. So the reflected region would be something like this over here, whatever, something like this. And I have shells going through there that look kind of like if I pick like a width and I make a shell. Whatever, something like that. So I'm going to do the same thing. If I take that shell apart, and I lay it flat, something like that, I don't have to do anything with the function. I can leave it exactly as it is. So here's my width, here's my length, here's my height. So I'm going to integrate the length times the width times the height. The width is dx. The height is the function. And then the length is 2 pi x. So I'm going to put the 2 pi on the outside, integral of x sine x dx, and my bounds are the same. I'm not messing with anything. I'm just doing it a totally different way. Which some of the ones that you did, it would have been much more elegant to do it this way. So there's a shell, and I'm going to go from pi over 4 to 3 pi over 4, make all these little nested shells, and then this is, remember, this is the limit as a sum goes to infinity, which is eventually what we did with series. Do you see, if you did not have a calculator, how would you integrate this? Excellent. Ultraviolet blue. So your u, and I'll just set it up because it's just so much fun. U equals x, d is dx, and then dv is sine x. So v is negative cosine x, and you'll have x cosine x minus the integral of negative cosine x dx. And then you evaluate all of that between pi over 4. You get this nice answer. I don't know. I'm not going to do it. And then you do the same thing for this. So pi over 4, 3 pi over 4. Look at how gorgeous that is. I'm just so happy about that. And then whatever that answer is. But if you're doing it the way that we've been working on these, you would probably stop right there. So let me get a little, I don't know, let me get a check mark. If you understand what's going on with this, just a check mark. Yay! Okay, we are breaking out. Yes, there we go. So I want you to do this one too, and there's something interesting that happens with this that we'll talk about when we get back together again. But you're going to be in groups of 2. We have 11. That's perfect. Okay. So groups of 2. We're going to break out. So just make sure your names are wherever you're doing stuff, and then we'll jump back together again. So I ripped us all back together again, and I just want to advertise. Now, some people just used the function 2 cosine x, and if you do that, then it's x measured from 0 to wherever the x is. But you have to take into consideration that the axis of rotation is over here, so that's why it's really teeny tiny, but this is actually 2 pi minus x. It's not going to be just x this time, because you're looking at the distance wherever x is from the center. The same way, if I were rotating it around this way, I would look at where x is from its center, which the previous one was, the center was here. So where x was measured from the y-axis out to here. But if you're rotating it here, that x is going to be in relation to the axis of rotation. So that was one thing. A lot of people got that, and that was one of the things I wanted you to see if you could recognize that. So this is length times width times height, and this is the answer that your calculator will pop out. And my question to you is, what is up with the negative? Why is that giving me a negative answer? And the calculator is not lying as such, if this is what you put in. And I know volume is positive, so I could ignore that and say, I don't know what it's doing, but I know volume is positive, so I'm just going to erase the negative. See, a little magic happens. Do you see, can you see what is going on making this negative, though, in the setup. And while you're doing that, I'm going to write this in integral form. That's like the format is right. But think about that. Why is that giving me a negative value? Any ideas for that? Oh, well, good. I didn't even see that. Yes, it's under the x-axis. Those y distances are under the x-axis. Now, the real thing that you need to realize is that you're looking at this as a distance. So you could say, okay, from 0 to here, and really call this height, instead of just 2 cosine x, say it's the top curve minus the bottom curve. So this is top minus bottom. See what I'm talking about? So it's this minus this. You also can just regard it as a positive. That's the other thing you can do. Say, well, I know sometimes it's going to give me negative because the setup is like this. There's nothing that's being squared, so it's not automatically going to be positive. The real reason is that you're looking at this as a distance, which is a top minus a bottom, and that's going to put a negative here, and it's going to result in a positive answer. So you could either put the negative there, you could put the negative out here, but that's the purpose of it, and then that will obviate this, and you'll get 78.957. Somebody got like a really huge number, and I think you probably just forgot something. I don't know what happened. Does that make sense? Give me a little emotion, a little happy face, clapping hands, yucky face. I don't get what you're talking about, lady. Lady, lady. Lady, what have you done? Yeah. Wish I'm going to miss you guys. I really am. It's really sad. And seniors, this is the last time I will see you, as it were. Today's the last day for your classes. Juniors, we're going to go on. We'll talk about probably trig substitution. I might go into some multivariable stuff just so you can get a little toe in the water. Okay, so if you're ready to go, it's so sad. I have an exit ticket, which is just a survey, like how did the exam go, blah, blah, blah. You can click on this. That's a live link. And I will see you on the flip side. And I'll also stop